Yes. Good morning. Good afternoon, everyone. Good afternoon, everyone. Yes. So tell me what we discussed in the last class. Fast. First thing is mole concept. Next. Just give me clear answer. So tell me. Mole concept. The next there interconversions, and the next stoichiometric calculation. Stoichiometric calculations. Okay. So in these stoichiometric calculations, today we need to discuss about an important topic, that is like limiting reagent and excess reagent. This is one of the most important topic to be understood. Okay. Next. After this, what we discussed? Percentage composition. The next empirical formula and molecular formula, and questions related to this. And is there any other topic we discussed other than this? Law of conservation of mass, that basic one. Okay. Yeah. Now we will be discussing this. Now tell me, what is the relation between empirical formula and molecular formula? Yes. Molecular formula equals to N into empirical formula. So what I am saying, molecular formula equals to N into empirical formula. For example, I am saying CH3COOH. Now if this is the molecular formula, what is its empirical formula? Do you got what I am asking? Yeah, tell me. Yeah. So you can take simplest whole number ratio of these things, this number. Like you can write this formula as C2H4O2. So this is the molecular formula. But what I am asking? Empirical formula. The simplest whole number ratio, what I can make? CH2O1. So taken twice. So what is the simplest whole number ratio we have? CH2O. Okay. Now you got now. So what is our N value in this case? 2 is our N value. Okay. Now one more relation I will tell you. Now what is its molecular weight? Tell me fast. What is the molecular weight of this thing? Acetic acid. Fast. Do it. So C2 means 12 into 2. 24 plus 4 plus 32. How much it is? 60. Okay, so molecular weight of acetic acid is 60. Now what is a like empirical formula weight? This one, what is empirical formula? CH2O. What is its empirical formula weight? 12 plus 2 plus 16. So you got 30. Okay, so now you can also get your N value, or you can also get your empirical formula weight from this N and molecular formula weight, or you can also get your molecular formula weight by multiplying N into empirical formula weight. So now empirical formula weight is how much? 30, and N value we got for this is 2. So you got molecular formula weight also from this. Okay, so why I am saying this very simple one here? Yeah, after some time I am going to show you one question related to empirical formula weight and molecular formula weight. There you need to use this concept. Okay, not now, after few more discussions. Okay, right. So yesterday you have solved this question. Yeah. So the next stoichiometry also started, and limiting reagent, excess reagent we will discuss now. See, during a chemical reaction, what we need to do? How much quantity of product is formed? We can say using the stoichiometric calculations right now. So see here, we need to produce water. So for that, H2 plus O2 should be reacted. So balance that equation. Is this balanced or not? Balanced. So 2H2 plus 1 O2 gives rise to so now it is a balanced equation. Take the stoichiometric coefficients 2, 1, 2. So this is how the stoichiometric relation we have. Okay. So now you just read what do we mean by limiting reagent and excess reagent. See, if the reactants are not taken in the stoichiometric ratios, then the reactant which is less than the required amount determines how much amount of product is formed. For example, you are doing a chemical reaction. Okay, for example, we are producing water. So for production of 2 moles of water, how many moles of oxygen is required? 1 and how many moles of hydrogen is required? 2 moles. But what I am doing, when we are performing the reaction, so I have taken 1 mole of O2 and 1 mole of H2 only I have taken. Now tell me how much quantity of water produced, they will ask. Do you got what I am asking? See, for production of 2 moles of water, we require 2 moles of H2 and 1 mole of O2. But how much I am giving to you now? 1 and 1. So how much amount of water it is producing, I am asking you. 1. So how we are saying, see, the one which is in lesser quantities, now tell me. See, required is 2 moles. But how many moles I am giving you? 1 mole only giving. So this is less than the requirement now. So this is the limiting one. So this is in the limits now. So one which is in lesser quantities, we should call it as limiting reagent. So in order to produce this, we need H2 and O2. The one which is in less quantity is considered as so that less quantity, the limiting reagent is there now. So that will decide how much amount of product should form. Okay. So now read these statements once again, these lines. Try to understand, don't shout. Okay. If the reactants are not taken in the stoichiometric ratios, then the reactant which is less than the required amount determines how much product will be formed. Okay. And it is known as limiting reagent. The reactant which is present excess quantity or in the excess amount, that will be called as excess reagent. Okay. See, for example here, for every 2 moles, like see, for every 1 mole of O2, how much quantity we require? 2. But I have for every 1 mole of O2 we require 2 moles. But how much we are having here? 1 mole only we have. So it means H2 is now considered as a limiting reagent. So now our calculation should be done with respect to limiting reagent only. What I am saying, our calculation should be done with respect to because that fellow only lesser in quantity. So he will decide how much amount of product should be formed. Okay. So now see, for every 2 moles how much it is required? For every 1 mole how much it should be required? See, half mole only now. So out of this 1 mole, so 0.5 mole, 0.5 mole. So out of this 1 mole of O2, so 0.5 mole will react with H2 and forms how much amount of product. See, if it is 2, here it is 2. If it is 1, here also it should be 1. So by reaction of 1 mole of H2 and 0.5 mole of O2 gives you 1 mole of H2O. It means out of this 1 mole, how much amount it is reacted? 0.5. It means 0.5 is being remained unreacted. Excess only now. Is it participating? Only 0.5 is participating. So I can say this is excess reagent. What is the quantity it is remained unreacted? 0.5. It means after performing the reaction, so quantity of H2 will be remained 0. So quantity of O2 remained is half. So quantity of H2O formed will be 1 mole. Is this clear? Okay. Now the same story, they may ask you in terms of weight. It means grams also. See, instead of saying 1 mole of product formed, you can say 18 grams of water formed or product formed, we can say. Yes or no? Yeah. So instead of saying here 1 mole of H2 is given, you can also call it as 2 grams of H2 is given. Yes or no? 1 mole H2 means what is its molar mass? 2 grams. Instead of saying 1 mole of oxygen is given, we can say 32 grams of O2 is given. So 2 grams reacting with, is it reacting with 32 grams or only 18 grams? Yes. So be clear here. For 1 mole it is 32. But how much it is reacting? Half mole only now. So it means only 16 grams is reacting, 16 grams is remained excess. Do you got what we are discussing? So when you are doing the calculations at the beginning, you do with respect to number of moles. Okay, then slowly extend it to grams. See, like weights, because you know, like general formula, like number of moles equals to given weight by molar mass. So number of moles into molar mass gives you weight. That's it. So you can do with respect to moles, and then next you can convert into weights also. Okay, that's it. Okay, now read this question once what they are saying. If the reaction mixture contains 2 moles of H2 and 2 moles of O2, then only 1 mole of O2 will be used up, then 1 mole remains left over. Therefore, in this case hydrogen, see this is whatever we have discussed, the same explanation is provided there. Okay, so tell me this assertion reason question. No sound. So tell me, the mass of product formed in a reaction depends on yes or no? Yeah. So then next, what is its reason? Limiting reagent reacts completely in the reaction. Okay, only excess reagent remains unreacted. So first option, like both assertion reason are correct and reason is correct explanation of A. Okay. So now yesterday I have given this question when you are doing study over time, I mean. Yeah. So how can you do this, tell me? See, how many moles of ammonia produced? It means ammonia produced by 5 moles of hydrogen. It means, first of all, tell me what is that ammonia process, production process, that one? H2 plus? So what is the name of the reaction? Haber's process. Okay, N2 plus H2 gives rise to, but balance the reaction? Okay, to NH3. So is it balanced? 1, 3, 2. So how to balance? See, 2 nitrogen atoms are there, 2 nitrogens. 6 hydrogen atoms, 6 hydrogen. Perfect. So this is the mole ratio we got. So for every 1 mole of N2, how many moles of H2 is required? 3. So that you are going to get a 2 moles of product, ammonia. Now what they are saying, how many moles of ammonia produced by 5 moles of hydrogen. So hydrogen is how much they have taken? 5. So they are not talking about nitrogen. So don't worry about this. So just calculate with respect to hydrogen only. So for every 3 moles how much we are getting? 2 moles. So for every 5 moles how much we are going to get? So consider it as X. So I told now unitary method. So what to do? X into 3, 5 into 2. So X will be, so this will be 3.333 like that. We will get option 4. Is this clear, everyone? Yes, right. Sir. Okay, do this fast. Yeah. So how can we do this? The number of moles of hydrogen molecules are required to produce 20 moles of ammonia through Haber's process. It means same reaction that we have written. So N2 plus H2. So 1 mole, 3 moles, 2 moles. See, as per this equation, we are going to get 2 moles when I take 1 and 3. Yes or no? Yeah. But how many I want now? So this I want 20. So if in order to make this 20, so 2 into 10. So here also then tell me how much? How many moles? So 3 into 10. So it will be 30. So nitrogen if I ask? 10. Is this clear? If you are unable to get this, just take this as X. Find X value. Unitary method. 3 into 20 equals to X into 2. Okay, same answer you will get 30. Same for this one also you do. Okay, everyone clear with this? Okay. So answer is next. Okay, so we'll discuss about this percentage yield. Okay, see, we will be doing, like we are studying this means definitely we are going to do some chemical reaction, might be in the future. If you become a scientist, then you need to perform all these things right now. Okay, so here generally during a reaction, the theoretical whatever we are doing now, see here how much you told in the previous question, how many moles you told, what is the amount of product formed, something like 30 moles, like that we are saying. So all those calculations are theoretical calculations. What is that? It means as per theoretical calculation we are saying 100% that product is formed, or maximum amount of product is formed, we are saying that is what we get from the theoretical calculation. But when we are doing practically, definitely the amount yield will be either equal to the theoretical calculation or less than that value. So it will not cross that now. Okay, and we know during a chemical reactions along with our products, most of the time some byproducts will also formed. It means our experimental yield will be definitely less than the theoretical yield. Yes or no? You got what do we mean by theoretical yield and experimental yield? When we are doing practically, the amount of product formed is considered to be experimental yield. Okay, so now we are going to take the ratio of that experimental yield to the theoretical yield. So that gives you the percentage of yield. It means, let us say A plus B is some reaction is taking place, we are going to get C, okay, and some byproducts also formed, some D. Okay, so I am saying percentage yield, it means the quantity of C formed is some 80% I am saying, this is formed is 20% I am saying. Okay, like this. So how we will get these values? You can take this formula. Percentage yield equals to actual yield by theoretical yield. Actual yield means that you are doing experiment. That is what experimental yield by theoretical yield. Okay, now read these ones. See, due to practical reasons, the amount of product formed by a chemical reaction is less than the amount predicted theoretical calculations. Yes or no? The ratio of amount of product formed to the amount predicted into 100 gives you percentage yield. Okay, so this simple formula you should remember. Now we will do this simple question so that you will feel more clear about this. See, for a reaction, what is the reaction mentioned? 2A plus 4B forming 4C. Okay, so initially only 2 moles of AB is taken and 1 mole of C is formed. Okay, then identify the limiting reagent and excess, identify the limiting reagent and excess reagent, and what will be the theoretical yield, the percentage yield we need to, theoretical yield and percentage yield we need to calculate. See, they are saying limiting reagent, excess reagent, theoretical yield means that we have studied in the previous question. So tell me, first take the stoichiometric relation here, what we have from the equation, write those 2, 4, 4. This is what the data from this equation right now, but they are asking us to take this one. Now given, what they have given? 2 moles of A as well as 2 moles of B. Now we need to calculate how much amount of product is formed. This calculation is theoretical or experimental? Theoretical only. 2 moles are given and asking us to find amount of C formed. So how can we do this, tell me? See, for every 2 moles, how many moles of B is required? 4. It means for every 2 moles, how many moles of B is required here? 2. As per the equation you tell me, for every 2 moles it is? 4. It means from the given data for every 2 moles, here also how much it should be required? 4. But how much they have given? 2. So it means which is lesser quantity they given? B is less in quantity now, so now our B is considered to be limiting reagent. So now what we need to do? Your calculation should be done with respect to limiting reagent. Since this is limiting, see, for every 2 moles, how many moles is required as per the equation? 2. For every 4 moles, how much it is required? 2 moles. It means for every 2 moles, it should be 1. So out of these 2 moles given, 1 mole will react, 1 mole remains reacted. Okay, so now who will decide our amount of product formed? So for every 4 mole, as per the equation, it is giving 4. So for given 2 moles, it will be also 2. Okay, so amount of product formed will be 2. Okay, is this clear? So now tell me, what are the calculations we got till now? Okay, we will go to that. Wait, this is what we are doing, theoretical calculation. As per this data, theoretical calculation is like this. Yes or no? Okay, so now tell me, after you are doing this reaction, how much amount of product is formed? 2 moles. How much amount of this reagent is remained?
1.
Limiting reagent na? Inkenta migilindi? 0. This one? 1 mole is remained unreacted. Okay, up to here it is clear na? మళ్ళీ ఒకసారి రిపీట్ చేశాను, ఆగండి. Okay, listen. You just read question, so just forget about this. ఆపేసేయండి ఇంకా. You just forget about this and do the remaining things. What they are saying, 2 mole, like this equation is given. Okay, as per that equation I have written this balanced stoichiometric coefficients. Then next what they are saying, if they are saying, if only 2 moles of A and B are given, okay, then how much amount of product will be formed? You just calculate theoretically. How much we'll get from that? See, for every 2 moles, as per the equation we required 4. But here it is 2 only given, here it is 2 only given, and asking us to find how much amount theoretically, you tell me they are asking. So do it. How can you do that? So for every 2 moles we require 4. Here also 2 is there. It should be given 4, but they given it only as 2. It means this is less quantity they given now. So our calculation should be done with respect to this less quantity. Okay. So for every 4 moles, how much it should be? 2. It means for every 2 moles it should be also 1. Okay. Here it is halved. Here also it should be halved. Do you got what I am saying? Okay. So that out of these 2 moles, 1 mole is reacted, 1 mole is remained excess, that is unreacted. Okay. The resultant product formed will be, for every 4 it is 4. For every t it should be 2. Is this clear? Okay. So this is the amount of product you got by theoretical calculation. Yes or no? Now see, they are saying then when these are reacted experimentally, how much it is formed? 1 mole is formed when they are performing experiment. So now percentage yield if I ask, so how you will do this? Experimental yield by theoretical yield into 100. So experimental yield is how much? 1. Theoretical yield is how much? 2. Into 100. So it means what is the percentage yield? 50%. So do you got what we are doing here? Okay. So now what are the questions they mentioned here? Identify the limiting reagent. Yes, identify. This is limiting. This is excess. Next, what will be the theoretical yield? What will be the theoretical yield? 2 moles. Wow. Next, percentage yield means? You got everything from this? Yeah. So make a note of it, and if you have any confusion, please ask me. Fast. Okay. So now I have given you one question previously. I mean, some small explanation I have given about empirical formula and molecular formula at the beginning. Okay. Now read this question. The empirical formula of a compound is C2H5O and its vapor density is 45. See, now I will tell you one formula. Vapor density is equals to molecular weight by molecular weight of that compound by molecular weight of hydrogen. What I am saying? Vapor density is equals to molecular weight of the given compound by molecular weight of hydrogen. Hydrogen means hydrogen molecule, no? So what is its molecular weight for hydrogen? 2. So we can fix this number as 2. So here the compound may changes depending upon the question, compound may changes. Now here they are saying some vapor density is how much? So vapor density is 45 means what is the molecular weight we'll get for that then? Tell me. Molecular weight will be equals to vapor density into 2. So it will be 45 into 2. So it will be 90. So this is your molecular weight. Then next read the question. What is the molecular formula of the compound? See, empirical formula is given. Okay, now what they are asking? See, empirical formula is given, molecular weight is given, asking molecular formula. So what is that relation I told you? Tell me once again. Molecular formula weight equals to N into empirical formula weight. Right now. So what is the molecular formula weight we got? 90. And now what we need to do? empirical formula weight you need to find. From this formula you can find its weight now. Tell me.
45.
So for this 24 plus 5 plus, so it will be 45. Okay, so here you got 45. So your n value is how much? 2. If n is equals to 2, here this is empirical formula now. So what is the relation? Empirical formula equals to empirical formula into n equals to molecular formula. So empirical formula is C2H5O multiplied with 2 gives you C4H10. Do we have that option? C. That is your answer. Okay, is this clear everyone? Yes. Yes, ma. See why this 2 is there? See, it is vapor density means it is a relative density. It means we are relating the vapor density like molecular weight of one compound with the molecular weight of hydrogen. So hydrogen molecular weight is fixed now. That's why we are taking that fixed value here. That's it. It's a fixed formula, you can remember. Okay, next. Next. Moving forward. So next. This one. The average molar mass of chlorine is 35.5. The ratio of Cl35 and Cl37 in the naturally occurring chlorine is close to. Okay, see, read the question once again. See, it's an average molar mass of chlorine is this much. Okay, it means when you are extracting chlorine from its origin, wherever it the source we have. Okay, so we are going to get, see, any element if you extract, so it will be a combination of all its isotopes. For example, if you are extracting carbon, okay, so from this extraction we will get carbon 12, carbon 13, carbon 14. Like that, all the isotopic mixture you will going to get when you are extracting it. Similarly, when we are extracting chlorine, we are going to get Cl35 as well as Cl37. Okay, so because these are the two isotopes for chlorine. Okay, up to here it is clear. Okay, now they are saying average molar mass now. It means whenever we are expressing molar mass of chlorine, it is the average of all the isotope it has. Similarly, average molar mass of carbon means it is the average of all these isotopes. Okay, is this clear up to here? Okay, so now I will be generalizing a formula to calculate this. Average molar mass is equals to summation of percentage abundance multiplied with its molar mass, its atomic weight by 100. Okay, what is that formula? Summation of percentage abundance into atomic weight. For example, this isotope is there now, Cl35. Okay, see atomic weight of this one is how much? And for this isotope it is how much? It means this will be, see what I told you, when you are extracting from the earth crust, you are going to get different possible isotopes. Let us say, see total mixture whatever we are taking, if I say that is 100%, okay, in that 100% some amount of Cl35 will be there, some amount of Cl37 will be there, yes or no? Okay, so now I am saying the Cl37 amount is X. How much I am saying? X quantity of Cl37 is there out of this 100. Then remaining composition is how much? 100 minus X will be for this Cl35. Do you got what I am saying? Okay. So now look at this. Average molar mass, how much they are saying? So this is 35.5. Okay. Can I send this 100 this side? Yeah. Into 100 is equals to percentage abundance. What is the percentage abundance of Cl35? 100 minus X. 100 minus X. And what is its atomic weight? 35. Plus summation means this one plus that one. Like how many isotopes are there? Add all those things like this. Okay. Next one is what? X into 37. That's it. 100 already I have sent this side. Okay, up to here it is clear now? Okay. So this becomes how much? See 0, 0, 3, 3, 5, 5, 0. That's it now? That's it. Next, this one 3500 minus 35x plus 37x. Is this clear up to here? Okay. If I send this here, this side, 50. 3550 minus 3500 is 50 equals to, this one is how much? Plus 2x. Okay, this will be how much? 25. It means which one we have taken as x? 37 we have taken as x. So this 37 will be how much percentage existing in the nature earth crust? I mean from the extraction it will be 25. 100 minus 25 is? 75. So from here what you got? So Cl35 will be 75. Cl37 will be 25. Now what they are asking here? Ratio. Ratio of 35 to 37 is how much? 3:1. So where do we have that option? That is your answer. Okay. Is this clear? Now what is the formula we have used here? Average molar mass equals to summation of 100. Okay. Use that and calculate like this. Okay. Clear everyone? Yes. Any doubts are there? You please ask me. Okay. Don't sit silent like thinking that what other students will think about me if I ask the doubt. Okay. This question came in which exam? Same question asked in EAPCET also in NEET also with a small variation. See what they told here, average molar mass is given now. So now what I will ask is, what is the average molar mass of chlorine by giving the percentage abundance of Cl35 is 75 and Cl37 is 25. So what to do in that case? So this is what you need to calculate. Here 75 into 35 plus 25 into 37 by 100. By simplifying you will get the answer. Okay. Now the same formula can we can remodify based on the ratios also. What is the ratio of abundance of Cl35? Cl35 is 3, 37 is 1. So here the formula can be remodified as like this: average molar mass equals to 3 into 35 plus 1 into 37 by 100 anoddu ippudu. 3 and 1 we have taken now. What is the sum of those? 4. You take 4 in the denominator. Is that clear? Yeah. Instead of saying 75, I am saying 3. Instead of saying 25, I am saying 1. Instead of saying 100, I am saying 4. Like that. Done? Okay, done. Let's move. Okay, so up to here we are almost done with first chapter. Okay, so what the thing remaining here, you need to practice the questions. Okay, so once you get the material, you can solve from that. So till that time I am giving you 30 questions every day. Okay, you just solve those questions first. Okay, now I mean few more topics are there, like concentration term is the main thing we need to discuss from mole concept. I mean some basic concepts of chemistry. Again same topic comes in the solutions also. Here itself I will cover. Okay, if required I will revise at that time, but try to listen now itself. Okay, so what do we mean by concentration terms here? See, in chemistry we are dealing about concentration. See, sometimes we will say the acid is very strong or very weak, we will say. Again, acid is very concentrated or very diluted, we will say. Okay, so I think most of you are from class 12, you already performed that salt analysis and all those things. So there you will be seeing reagent bottles like HCl, sulfuric acid. Okay, if you see the pure sulfuric acid or something like whatever the thing they are brought, so if you open the cap it will be giving you fumes. Okay, concentrated one. But the one which they put on the desktops, I mean wherever it is, okay, it will be having no normal like water, it will be visible right now. So it means it's a diluted one right now. Okay, so now what makes the difference? The quantity of sulfuric acid present in that solution. See, what do we mean by solution? So it generally it is of like solute plus solvent you are writing. Okay, so now let us say I am saying sugar solution. In the basic understanding purpose I am saying sugar solution. Okay, so to the water what I am adding? Sugar I am adding. Okay, so now whether this sugar solution, tell me whether it is homogeneous or heterogeneous. So whenever I am saying solution, it should be homogeneous mixture. Homogeneous means what? Single phase should be there. Complete solution should have only one phase. It can be gaseous phase, solid phase, liquid phase, but completely it should be single phase. Okay, right. So now how much amount of sugar, like what is the concentration of this solution if I say? It depends on what? Quantity of sugar that you are dissolving in this water to make that solution. So it means, what do we mean by concentration here? It is the measure of amount of solute that has been dissolved in the given amount of solvent or solution. So what do we mean by concentration? It is the amount of solute that is dissolved in a solution. In the solution it is given with the concentration term. So now here concentration terms are different, like different types are there. Okay, so one is something like weight by weight percentage, volume by volume percentage, okay, weight by volume percentage. The next molarity, normality, molality, mole fraction, like that we have different terms. Okay, so one by one we will study now. Okay, so now first one, mass percentage or weight percentage. Say percent, it means if you are taking 100 grams of solution, how much you are taking? 100 grams. So solution is 100 grams. So solution definitely contains solute plus solvent. To make this 100 grams of solution, how much amount of solute you are adding? Okay, see, it represents mass of solute present in 100 grams of solution is called a mass percentage or weight by weight percentage. Okay, for example, here I am giving you one simple example. 30 weight by weight, 30 percentage or weight by weight I am specifying. Okay, of NaOH I am saying, NaOH solution. It means what you are understanding from this line? It means you are dissolving 30 grams of NaOH solute to make 100 gram of NaOH solution. Now tell me, what is the weight of solvent here? Array, you got 100. So in order to get here we have 30 grams of solute. Remaining 70 grams will be solvent. So you are mixing with 70 grams of solvent. Is this clear? Okay, so you just take weight of solute by weight of solution into 100. Okay, what is that? Weight of solute by total weight of solution into 100. Is this clear, everyone? Okay. Next one. Weight by volume percentage or volume by volume percentage we have. See, weight by volume percentage means what? What I am saying? Weight by volume percentage. It means weight of solute in grams, weight of solute in grams present in 100 ml of solution. Now tell me, what will be the formula? Weight by volume percentage means weight of solute grams by volume of solution into 100. Okay, this is in ml we are taking. So now what is the units for weight by volume percentage? Gram per ml we got. Previous question, previous explanation for this, you tell me what is the units? Gram and also gram. Gram cancel. So no units. In which case it is no units? If both numerator denominator are same, no units. Okay, is this clear up to here? Next. So if you see sanitizer bottles, you know now? Okay, so you take any sanitizer bottle or you can observe in any alcohol bottle like whiskey or anything you can see. So what it will be mentioned? See, if you observe sanitizer bottle, it will be like 75% or something like that. Okay, some number will be there. So what that number says? Volume by volume. It means if you take 100 ml of that solution, 100 ml of that solution contains whatever the quantity they mention, so it means 75 here means 75 ml of that alcohol will be present, remaining is our solvent. Okay, it means 25 ml will be our solvent, like that. Okay, so now read this definition. It represents volume of solute in 100 ml of solution. Okay, so you just take volume of solute by total volume of solution into 100. Now what is the unit here? No unit. Volume by volume means no unit. Okay, next mass by volume, just now I discussed already. That's it, done. Let's move forward. Just one simple formula, you can generalize it to like everything. If I say weight by weight percentage, weight of solute by weight of solute by weight of solution into 100. Volume by volume means volume of solute by volume of solution into 100. Try to say one or two times, you try to say with me so that you can also remember, otherwise it is difficult. Next, mass by volume percentage means so no need of shouting too much, you can say with like that cute voice, not like shouting. Okay, so mass of solute by volume of solution into 100. Okay, that's next. Parts per million. So it means number of parts of solute by total number of parts of solution into million means 10 power. There it is percent. Here it is per million. Million means 10 power 6. That's why you can take number of parts of solute by total number of parts of all components in the solution into 10 power 6. Okay. Then up to here. Done? Okay, next. Okay, next one is what? Molarity. We'll use this most of the cases. Listen it proper. Like indicated with symbol capital M. Okay. So now we discuss about moles now. Okay. So the number of moles of solute present in 1 liter of solution. What is this? 1 liter of solution. Number of moles of solute present in 1 liter of solution. It means number of moles per liter. So what is the units for molarity? Mole per liter. Mole per liter is the units for molarity. Okay. Next. So how can you write this? M equals to number of moles of solute by volume of solution in liters. Okay. Up to here it is clear now. So in the short form I am writing M is equals to N by V. So what do we mean by N? Of what? Solute. By? Volume of solution. Okay, up to here it is clear. Now I am asking you one question. What is the molarity? What is the molarity of solution made by mixing 2 moles of glucose in 1 liter of solution? So what to do? 2 by 1. 2 mole by 1 liter. So 2 moles, 2 molar solution it will be. Okay. Now the same question. See, don't think this is like you are giving direct questions. I will make it. Okay, no issues. See, instead of saying 1 liter, I am writing this as 500 ml. Now tell me. So how can we do? See, this volume is in liters now. Whenever I am giving you volume in ml, you just take it like this. N by V. In ml, when you are expressing, multiply this with 1000. Okay, now tell me. 2 by 500 into, so it will be 4 moles. Okay, is this clear everyone? Okay, up to here it is clear. Next question is 90 grams of glucose. What I am saying, 90 grams of glucose dissolved in 100 ml of solution. So what is its molarity? Tell me fast. How much I have given? 90 grams of glucose dissolved in 100 ml of solution. What is its answer? Fast. So what is the molarity formula you got? Molarity formula enti? number of moles by here I have given 90 grams. Now convert that into how many moles? Its molar mass is how much for glucose? 180 you will get. So number of moles means, see, molarity means n by v we are writing, or n by v into 1000 we are writing. So I can write number of moles as weight of that substance, weight of that solute by molar mass of that solute, okay, into number of moles over. Next, that is 1000 by v in ml. Okay, now tell me, weight is given as 90 by 180, so it will be 2 times, it will be 2. So 1 molar solution it is. Is this clear what we are doing? Clear or not? Okay, 100 ml. Okay, you just tell me that. Okay, 100 ml means it will be 10 times. So 10 by 2 means, so 5 molar solution. Okay, clear everyone? Yes. ppm only. Next. Okay. After this, what is the formula I have given? First formula, N by V in liters, or this can be also written as N by V 1000 when I am expressing this in ml. So now I am writing this as weight by gram molecular weight into 1000 by V. See, this N I am writing like this. Okay, up to here it is clear. Okay, so next M is equals to weight I have now. What is this weight indicates? Weight of solute by, here volume is there now. What is this V indicates? Volume of V solution. This is weight of solute. Okay, into 1000 by gram molecular weight of solute. So solute from now onwards I am indicating with symbol B. Okay, so now you can see what is this formula? Weight of solute by volume of solution into 100. Percentage of what? Weight by volume percentage. So wherever I have this one multiplied with 1000 means what I can write? 100 into 10. So this one with this thing. So what I can make it? Weight by volume percentage into 10 by GNW of solute gives you molarity. Is this clear up to here? Okay. So next, you have that very basic formula in physics. What is that? Density equals to volume. So density of solution means mass of solution by volume of solution. So in the place of mass of volume of solution, I can write mass of solution by density of solution. Can we write it like this? So wherever I have like volume, there I can replace with mass by density. Okay, so in the place of mass I am writing just as weight, so that you will feel clarity. Okay, so here in this place I am writing what now? Weight by density. So molarity is equals to weight of solution as it is, weight of solute as it is, by, in the place of volume what I am writing now? Weight of solution. So solution I am indicating with symbol A. Okay. See this, it is in the denominator. So you place this in the denominator. Density goes numerator. So here I am writing density of solution. Okay, not solution. This is write it as solution. Okay, write it as solution. See, solute plus solvent gives you solution. So from now onwards I am fixing solute with B, solvent with A. Solution as it is, solution only. Okay, so can I write wherever I have volume of solution, there I am writing weight of solution by density. So I can write in the numerator that one. Okay, up to here it is clear. The next, what is the next thing here we have? 1000 into 1000 by gram molecular weight of solute. Up to here it is clear? Okay. So molarity equals to, see, weight of solute by volume of solution. Weight of solution. It's a ratio now. So what is it? Weight by weight percentage. Okay. So weight of solute by weight of solution into 100. It means percentage, weight percentage of that solution into density of solution into 10 by weight of solution. Okay. You need to remember these two formulas also. Okay. Is this clear up to here, these two formula derivation? So derivation is not important, but at least you need to remember these final outputs. Okay. Even if you forgot, you need to derive following these methods. Okay. Next. So what is the final first formula you have? Molarity equals to N by V in liters. See, if I simply ask you how many moles, what you can say? How many moles of solute? Molarity into volume of solution in liters. If I ask you in ml, if I give volume in liter mLs, divide here by 1000. It means that comes from here. Okay, see, m into V by 1000 is equals to N. So we will use that formula later. Just remember all these formulas. So don't by heart, try to understand what we discussed. Okay, what do we mean by molarity? Tell me first. Okay, number of moles of solute present in the 1 liter of solution. So the formula becomes N by V in liters. If it is in ml, N by V into 1000. If the weight is given, weight of solute is given, weight of solute by molar mass of solute into 1000 by V, volume of that solution, like that. Next, weight percentage is given means, molarity equals to weight percentage into density of solution into 10 by molar mass of solute. Done up to here. Next, if weight by volume percentage is given, molarity equals to weight by volume percentage into 10 by solute. That's it. Clear up to here? Right. Next. See, now till now we have discussed a few concentration terms right now. So whatever the formulas we discussed till now, wherever you are seeing volume term in the formula, what I am saying? Whether in the numerator or denominator, wherever you have seen this V, so that depends on temperature. That particular concentration term depends on? It means if I change the temperature, that concentration term value also changes. For example, molarity means what is the formula we discussed? N by V. So V is involved now. So what about its molarity now? What is the effect of temperature on this molarity? Changes. It means what do we mean by effect of temperature? See, I am calculating molarity of a particular solution at 25 degrees Celsius. Okay. Now same thing I am calculating at 90 degrees. Now the value will be same or changes? Changes. This is what effect of temperature means. Okay, I will show you one question on that. But you got now what do we mean by effect of temperature means? So what are the terms I told you? One tricky way to look at the formula or the definition. If it involves anything volume either in the denominator or in the numerator, that can be considered as temperature dependent term. If there is no volume term, temperature independent term. Okay. Now tell me, weight by weight percentage is temperature dependent or independent? Independent. Now look at this, mass percentage is temperature independent or dependent? Independent. ppm, mole fraction also independent, I will tell you. Next, molality I will tell you, that is also, these are the independent terms. Okay. Next, molarity, weight by volume percentage, dependent. Okay. Volume by volume percentage. So you got how to identify this. Okay, simple now. So what to check? So now you might be having, sir, why it is like that? See, if you increase the temperature, what happens to the molecules? Their kinetic energy increases now. So expansion takes place. Like the molecules may get expanded. It means there will be increase in the volume. If volume is changed, whatever you are dividing, multiplication, that number also changes now. That's why wherever volume term is involved, that is temperature dependent. Okay, solve these two questions first. Okay, just follow this. Molarity of solution if 6 grams of urea is dissolved to make 1 liter of, it means you need to take one beaker. How much volume of that solution? 1 liter. So what you are adding? 6 grams of urea. So solute is what? Urea. So what is the formula of urea? NH2 twice CO. So if you calculate molar mass, how to calculate molar mass? How many nitrogens are there? So CON2H4. Like this we have. So carbon is 1, so 12 plus 16 plus 28 plus 4. So if you sum this, you will get 60. So 60 gram per mole is its molar mass. So now molarity I am saying now. So given, see, number of moles by volume of solution we have in liters. Okay, but number of moles is not given now. How can you calculate number of moles? 6 by 60. So 6 by 60 is how much? 1 by 10. It means 0.1. How many liters they have mentioned? So 1 liter. So this is 0.1 mole by 1 liter. So 0.1 mole per liter is your answer. Okay, is this clear? Okay, next. Next, this one. Molarity of 4% weight by volume NA weight solution is. So what is the relation between weight by volume and molarity? Weight by volume percentage into 10 by gram molar mass. Okay, so it means this one is how much? 4 into 10 by molar mass, 40. So 1, that's it. This is how you need to do. Everyone got this? Yeah. So first you need to make this question, this formula list. See, don't write all the theory that is present on the board. Just at least make that formula sheet. Okay, it will be easy for revision purpose. Because do this fast. Done? Fast. Again, from concentration terms, definitely one question will be there in your final EAPCET exam. Okay, without concentration term, there will not be any question paper. What I am saying? Without concentration terms, there will not be question paper. Like that. That much important it is. Okay? So tell me, how can we do this? Molarity of solution when dissolved, when 4.9 grams of sulfuric acid dissolved in 250 ml of water. So what the data they have provided? Weight of the solute, volume of solution. So what to take? Number of moles means, like this we have, it is 250 means you can take here ml, so multiply this with 1000. So here it is weight of solute by molar mass of that solute 1000 by V. Okay, now tell me here, what is the weight? What is the molar mass of sulfuric acid? So remember, for sulfuric acid it is 98. Okay, so every time no need of calculating, now itself you remember. Here 250. So 250 means this is 4 times. This one I am writing 10 power minus 1 aside. So this will become 2 times. So this will be 2. So it will be 10 power minus 1 into 2 means 0.2. So this is the molarity of the solution. Okay, so option B. అరే మీకు ఇంకొక చెప్తా, చాలామంది ఇప్పుడు నేను అబ్జర్వ్ చేసింది ఏంటంటే క్వశ్చన్ సాల్వ్ చేయడానికి చాలా ఇబ్బంది పడుతున్నారు. అసలు వాళ్ళకి ఎలా సాల్వ్ చేయాలో అర్థం అవ్వట్లేదు. ఫస్ట్ మీరు అసలు ఆలోచించట్లేదు ఎలా క్వశ్చన్ ఎలా మొదలు పెడదామని. జస్ట్ ఫార్ములా ఏదైనా ఉందా అని వెతకడం, పక్కలో ఏదైనా చూడడం, ఇలా చాలా మంది మైండ్ సెట్స్ అట్లా ఉన్నాయి. సో ఫస్ట్ యూ థింక్ అబౌట్ క్వశ్చన్, వాట్ ఈస్ ద డేటా ప్రొవైడెడ్, వాట్ ఈస్ ద బెస్ట్ వే వీ కెన్ సింప్లిఫై ఇట్. ఓకే, సి ఎంసెట్కి, ఎంసెట్ అయినా నీట్ అయినా ఏదైనా మీరు ఏం ప్రిపేర్ ఎంసెట్ అనుకోండి, ఏం ప్రిపేర్ చేయకుండా పోయి రాస్తే ఒక 30K ర్యాంక్ వస్తుంది మీకు అనుకోండి ఇన్ కేస్. ఓకే, ఇప్పుడు ఎంతో కొంత కొన్ని చాప్టర్స్ మీకు ఫేవరెట్ చాప్టర్స్ ఇక్కడ క్లాసెస్లో అర్థమైనవో ఎగ్జాక్ట్గా వాటిపైన కరెక్ట్గా ఫోకస్ చేసి ఉన్నారనుకోండి, అట్లీస్ట్ ఆ ర్యాంక్ కొంచెం బూస్ట్ అవుతుందా అవ్వదా? బై లక్కీ ఛాన్స్ ఇఫ్ ఇట్ ఈస్ ఫాలింగ్ బిలో 10,000 ర్యాంక్, you are going to get a good college. Otherwise normal college, normal days. Okay, so ఈ 40 days ఫ్రెండ్స్ ముచ్చట్లు అవి ఇవి కొంచెం తగ్గించుకొని try to focus on the questions or the concepts that are much important for EAPCET. ఓకే, సో ఏం డిస్కస్ చేయట్లేదు కదా, క్లాస్ కూడా బోరింగ్గా లేదు కదా, కొంచెం ఇన్వాల్వ్ కాండి. మీరు కొంచెం ఇంకా ఎక్కువ చేస్తే వీ కెన్ హ్యావ్ అదర్ యాక్టివిటీస్ ఆల్సో. ఓకే, దెర్ ఆర్ సమ్ సింగర్స్. Okay, so we can introduce them like that. Okay, done with this? Done with this? Yes, next. Next term is what? Molality. So symbol is small m. So previously it is capital M, here it is small m. So molality is equals to, so what it is saying, see, represents number of moles of solute present in per kg of, previously it is 1 liter of solution, that is solution, this is remember the difference, this is solvent, that is solution. So I can write number of moles of solute as NB. Okay, now present in what? Weight of solvent. So solvent ki symbol enti, what is the solvent symbol? I told you A. So weight of A, it should be in kg. So this is a simple formula to be remembered for molality. So in the simple way I can write M equals to NB by weight of A in kg. Okay, next. Now what will be the units for molality? Molarity is mole per liter. So it will be mole per kg. So the units here will be mole per kg. These units are fixed, they won't change for molarity and molality or whatever we are studying. Okay, next one. Do we have any volume term involved? No. So temperature dependent or independent? Independent. So temperature independent. Okay, next. Okay, see, they will say during the like question, they will say 0.5 molal. What they will say? 0.5 molal. See, this is L, molality. So they will say 0.5 molal or 1 molal, like that. If it is molarity, they will say 0.5 molar. This is the difference you need to remember. Okay, next. Okay, write this question, everyone. Write this question. This is a homework question. If you do this one question, most of the formulas will be revised. What is that question mentioned? Molarity, strength of solution of 18% weight by volume of glucose solution, and also its mole fraction. I am going to discuss them, but you write this question and keep it. Given density of solution is this much. Okay, everyone can try by tomorrow. Okay, next term is what? Mole fraction. So mole fraction, see, fraction means fractions, you know now. Okay, so it's a thing we are expressing fractions of what? Moles. Okay, see, generally solution means what we have? Solute plus solvent. Okay, now mole fraction is indicated with symbol chi or x, you can say simply. Okay, so mole fraction of solute, if I say, so what you say here, mole fraction of solute means number of moles of that solute by total number of moles. For example, this solution is made up of A and B now, so mole fraction of B means number of moles of that B by total number of moles. Total number of moles are what? Na plus Nb. So Na plus Nb. In the same way, you tell me mole fraction of A means what will be the formula? Na by N total. What is this N total? Na plus Nb. Okay, now you try to add these two, chi A plus chi B. Chi A means Na by N total. Okay, plus chi B means Nb by N total. So Na plus Nb means also N total only, na? Okay, so it means Na plus Nb also N total and denominator also N total. So if you cancel out it, so sum of mole fractions of a solution will be equals to 1. So Xa plus Xb is equals to 1. Or if I want only Xa, so I can say this as 1 minus Xb. Remember this, we will use this in the solutions chapter later. Okay. Tell me, is temperature dependent or independent? Independent. Okay, don't write all these things, just understand the formulas. Clear? Next. Answer me this. Mole fraction of glucose in the solution made up of 2 moles of glucose and 4 moles of so tell me, how can I do this? Mole fraction of glucose. So tell me, number of moles of glucose by number of moles of glucose plus number of moles of water. So it will be 2 by 2 plus 1 by 3. So you can write this as 0.33. So if I ask you mole fraction of water, 4 by 6. 4 by 6 you can say, or 1 minus mole fraction of glucose. Both gives you same answer. This is 0.6667, like that you will get 6 you can write. Okay. Next. Okay. See, instead of saying moles, I am giving you a question. Now tell me. Mole fraction of glucose in a solution made up of 90 grams of glucose that mixed with 90 grams of water. Yeah. Mole fraction of glucose in a solution that is made up of 90 grams of glucose plus 90 grams of water. It means what to do? First convert into moles. You know now basic formula. What is this 90 grams means how many moles? 90 by 180. So this gives you half mole. Number of moles of water is how much now? 90 by 18. So 5. Done? Okay. So Ng will be equals to 0.5 by 0.5 plus 5. So it is 0.5 by 5.5. So point can be removed. 5 ones are 5 11s are. So it will be around 1 by 11. So if you want to calculate, you can simplify it as something like 10. It will be again 0. So it will be 9s are. Something like this, you will get the answer. Is this clear? Okay. Write this question as a homework. Don't ask me to solve now. Done? Okay. Normality. See, molarity means what you have discussed, what we have discussed. Moles of solute by volume of solution in liters. Okay, similar to this, we have a new term now, normality, indicated with symbol N. So here, instead of saying moles, we will be saying here number of gram equivalents, gram equivalent numbers. Here number of moles I am saying, here number of gram equivalents. Okay, so what is gram equivalents I will tell you. So number of gram equivalents by volume of solution in liters. So here it is moles, here it is in gram equivalents, that's it. Okay, so now read this once. It represents number of equivalents solute present in, it means like this only now formula. Okay, now the units for this will be gram equivalents, gram equivalents per liter, that's it. Now tell me, it is temperature dependent or independent? Volume term is a dependent, that's it, done. Next one. So now what do we mean by equivalence? See, number of moles means what you have written? Weight by molar mass we have written. So similar to this, number of equivalents means take same weight by equivalent weight. See, this is molar mass or molar weight, molar mass. Here it is equivalent one. So now there is a relation between equivalent weight and molecular weight. So equivalent weight means molecular weight by its n factor. Okay, see everything is same, you just got a new term here. What is this? N factor. So what do we mean by n factor? You need to know. See, if I say HCl, how many H plus ions it is releasing? 1 H plus ion it releases. Similarly, if I say sulfuric acid, how many it is releasing? 2 H plus ions, na? Okay, so the N factor for HCl will be no 1. For N factor for sulfuric acid will be 2. It means the number of H plus ions or number of OH minus ions by a base released is called its N factor. Okay, so that value you should take here. Okay, now we want one simple formula, sir. We don't want all these things, means I will give you. See, equivalent weight means what you need to take? Molecular weight by N factor. See, the same thing I am placing over here. So weight as it is, equivalent weight means what I should write? Molecular weight by N factor. Can I write this here in the numerator? Yeah. So weight by molar mass? Weight by mass by molar mass? Yeah. So number of moles into N factor is nothing but? So now wherever I have number of equivalents, there I can write? So here I am writing N into N factor by volume. Okay. So now N by V means what? N by V. So capital N is equals to N into N factor by V we got. Okay. Now in the place of N by V I can write? So normality equals to molarity into N factor. This is the final relation we got. So now what is the relation between normality and molarity? Normality equals to molarity into N factor. Okay, done up to here. So tell me, for NaOH, what is the N factor? For CaOH twice. Now this is for acids base you are doing well. Now when I am giving a salt solution, for example salt solution means, okay, up to here it is finished. Yeah. See, whether it is see, I will tell you one generalized and tricky way to calculate N factor. See, whether it can be acid, whether it can be a base, whether it can be a salt, whatever might be it is, you just take total number of positive charges or total number of negative charges. For example, I have Al2SO4 thrice, like this I am writing. When I place this salt in the water, okay, it is going to give you 2 aluminum ions, each aluminum is in +3, and 3 sulfate ions, -2. So what is the total positive charge we have? Alright, here it is 3. How many ions we have? So 2 3s are, so its N factor for this salt will be, 2 3s are 6, like this. So total negative charge also, 3 2s are 6. So don't consider minus place, just take that number. So that is the N factor of that particular solution. Okay. Now tell me, I am saying 1 molar Al2SO4 solution, SO4 thrice solution. Then what is its normality? I am giving you 1 molar this solution. So what is the relation we got? Molarity, normality. Normality equals to molarity into N factor. So 1 into 6. So 6 normal solution you should say. Is this clear? Okay. Okay. Now write one more question. Everyone should answer this now. See, you should not take it light. Some people are not even starting the question. Like they just writing the question or simple things like this, some courtesy writing something they are doing and they are sitting simply in the class. Okay. So try to do some things in the class. I mean at least initiate somehow. Okay. Now I am giving you a question. Right. 4.9 grams of sulfuric acid. 4.9 grams of sulfuric acid. Then find sulfuric acid in 1000 ml of solution. then its molarity and normality fast. Done? So molarity means, how can you do this? Tell me fast. Weight of its solute, weight by its molar mass. How much? 4.9 by 98 into, so 1000 ml means 1 liter only now. So it will be 1 by 1000 by 1000, 1 here. So this will be how many times? 1 1 by 20 it will be. 1 by 20. So molarity like this means what we can write it as simply, see, if I make 0 point, here 0, 0, 0 cancel. Again one more 0, 10 by 2, that is 5. So like this you can write. So this is molarity we got. Now what I am asking you? What is the relation? So 5 into 10 power minus 2 into n factor for sulfuric acid? 2. So 2. So it will be 10 into 10 power minus 2. I can simply write 10 power minus 1, that is 0.1. Okay. So this is how you can write finally. Done everyone? Move forward. See, I am asking you one more question. What is the equivalent weight? This is again important question. Must see. See, the question will be equivalent weight of some substance they will ask. For example, equivalent weight of calcium they will ask. What is the formula for equivalent weight I told you? Yes, perfect. Molecular weight by n factor. So, tell me calcium belongs to which group? Second group. So, this first group elements, it means sodium, lithium, sodium, potassium. Whenever they are reacting with someone, they always exist in +1. Similarly, second group elements. So, what is the conversion from calcium atom to calcium ion to, like +2. So what is the charge you are seeing here? So its n factor becomes 2 now. So what is the molecular weight of atomic weight of calcium? Sorry, atomic weight of calcium will be 40, and its n factor is now how much? 2. So this will be 20. So 20 is the equivalent weight of. So is this clear? Okay. Now similarly, if I ask you what is the equivalent weight of sulfuric acid? What is the molecular weight of sulfuric acid? 90. What is its n factor? 2. Because 2 H plus ions it is releasing now. So 49, like this. Okay. Similarly, I am asking you one more question. Now what we can generalize? The equivalent weight will be taken as the molecular weight of that substance, by n factor. That's it. That's it now. You can remember like this. See, now the question will be like this in the exam. KMnO4, you know, potassium permanganate. So when it is reacting in acidic medium, what it is? Acidic medium. So now the change will be, what is the oxidation state of KMnO4 here, manganese here? +7. Converts into in acidic medium with whatever it is reacting. So +7 will be converts into +2. From where to where it is going? +2. Now 7 becoming 2 means whether that number is increased or decreased? Decreased. So it means electrons gained or lost? Lost. Gained. This is more positive means less electrons. Okay. So by gaining how many electrons? 5. So it is gained 5 electrons now. So during this process, potassium permanganate N factor will be the number of electrons gained or lost. So here it is gained now. How many? 5. So the N factor here will be 5. So now for this process, they will ask what will be the equivalent weight. What will be your answer? The molecular weight of KMnO4 by 5. Is this clear? Okay. So that same KMnO4, when it is reacting in neutral medium. In which medium? Neutral medium or slightly alkaline medium. So +7 converts into +4. From where to where? +7 to +4. What is the N factor you are seeing? 3. So now what its equivalent weight becomes? That molecular weight by 3. So the same KMnO4, when it is reacting in basic medium, like strong alkaline medium, basic medium you can say. Okay. So here +7 converts into +6. So now what is the change? So N factor will be 1. So now what is its equivalent weight? Molecular weight by 1. It means depending on the reaction, the equivalent weight will be decided. Okay. So you can write this in the short form as soon as, like, very fast. Don't waste the time. If it is done, we'll move forward. Done? Okay, let's move forward. Fast. Okay, the same story I will ask you in redox reaction chapter again. You should remember this. So, KMnO4 in acidic medium? +7 to? +7 to? What is the N factor? 5. In basic medium? +6. N factor? 1. Either in neutral or in slightly alkaline? +4. +7 to +4. N factor? 3. Remember this, we will discuss again. Okay. Next one is, see, I have two different solutions. See, here one acid is there. Here I have one acid and here one more. For example, both of them are HCl, let us say. Okay. But its concentration is M1 and having some volume of V1. Its concentration is M2 and volume V2. It means different concentrations, different volumes. Okay. Now I am mixing them to make a resultant solution. Okay. Now I am mixing these two to make a resultant solution. Now the concentration changes or remains same? Changes. Now what is that resultant concentration we need to find? Okay. So that I am saying M resultant. What I am saying? M resultant or V resultant. This is what I want. Okay. So what you need to take is M resultant into V resultant is equals to M1 V1 plus M2 V2. So if they simply ask what is a M resultant, what you can say, M resultant is equals to M1 V1 plus M2 V2 by V resultant. V resultant means what? V1 plus V2, like that. Okay. So that's it up to here. See, along with this, what I am doing is, along with these two solutions, now I am adding some quantity of water also. What I am adding? Water. So it means volume will be not only V1 plus V2, that whatever the quantity of water we have added. So in the denominator, what you need to take? V resultant becomes now V total. So what do we mean by V total? V total equals to V1 plus V2 plus whatever the volume of water we are adding, like this. Okay, is this clear? Okay. So what is the V resultant formula? M1 V1 plus N2 V2 by V1 plus V2. Similarly, if they ask in terms of normalities, N resultant will be equals to N1 V1 plus N2 V2 by V1 plus V2 plus so on, like that, whatever the quantities they are adding. Okay, right. Now do this question fast. Okay. See what they are mixing here? HCl and what I told you previously, both of them are mixed only, but both of them are acids. But here one is acid, another one is so here it is different way. See, when you are mixing both acids, should follow M1 V1 plus M2 V2 by V total, like that. Okay. If both bases also same, but one is acid, another one is base, means you should minus it, because what happens, acid base neutralization now. So M resultant becomes M1 V1 minus M2 V2 by V1 plus V2. This is fixed, V1 plus V2. So you just put mod over here. Okay, so that whatever the answer you will get, that will be positive value. Okay. So now look at this. Let us say this is acid, M1 V1. Do it separately, otherwise M1 V1. I am saying this is M acid, V acid. How much for acid they have mentioned? 0.1 into 20. So it will be 2. MB VB. How much it is? How much? 0.1 into 30. So this is 3. So we got now, who is greater, like which is greater here? 3. Base value is greater now. It means resultant solution will be basic. What I am saying, resultant solution will be basic. If acid value is greater, solution will be acidic. If both values are same, neutral. If this and this are same minus same means 0. So it will be neutral. Like that you can understand. Okay, basic way of understanding. Okay, so now tell me here which one I should take. So 3 minus 2 by V1 plus V2 is how much? 20 plus 50 I can take. So 1 by, so how can I write this? M resultant means? To this extra solution what they have added? Again extra 50 ml is added. So V1 plus V2 plus VH2O. So how much it becomes? 20 plus 30 plus 50, 100. So 1 by 100. So this is simply you can write 10 power minus 2. So we have any option? B. This is your answer. Okay, clear? Okay, let me check any questions are there for you. You can write this. After this, study over only, no? Yeah. You can solve this question easily. You can answer me now itself. Temperature dependent. Only molarity. Okay. Next, these two questions also you can try. Okay. So now today's your duty is to solve all these questions. that I have brought for you. Okay, all these are PYQs only. You can solve all this. Okay, so why I am scrolling like this? Because there are some live students, so they can take these questions and they can also practice. Okay, that's it. So this is about the session. Tomorrow we will be starting classification of elements, periodic table. Okay, so those who are watching it live, you can answer me these questions in the comment box. I will definitely look into it and I will tell you whether it is correct or not. So if it is wrong, we will discuss in the upcoming session. Okay, so thanks for watching. Stay connected with our what? NEET World YouTube channel. Thank you.